this is Helena and Dad.
Hello!
And in this video, we're going to be making our 2020 robot, or planning it more like.
For Piwars.
For Piwars. We're going to be calling it Bangers and Bash.
Can we do the backstory?
This is my dad's Magpi robot in the magazine that he's writing.
Raspberry Pi magazine, yeah.
Yes. And he's basing it on this, which is a lunchbox robot with a bunch of batteries, basically. And dun dun dun.
And in there we've got some fairly standard yellow motors. I mean, you'll see these everywhere with the matching wheels. We've got the L298N, which is like a big old motor controller, and they're not the most efficient. They waste power, they take up lots of space, but they're easy to work with, and they're kind of like, if you're doing a beginner robot or you're introducing a beginner robot, they're going to work. That's the thing, you know, there's not a lot that can go wrong with them. There's a Raspberry Pi Zero, there is a camera, and there's a little bit of breadboard there that does a bit of power distribution to the different parts. There's some line sensors on the bottom. There's a top panel with some distance sensors, light-based ones, and a power switch. That's the design I've got or been doing for this magazine robot. And I decided in the same vein to extend it into my Piwars 2020 robot. And Helena, as she pointed out, it is called
Bangers and Bash,
Bangers.
because it's a lunchbox robot. This is pretty much just a lunchbox with a bunch of components and cool stuff in it, but it's not going to be for long. And we think we might stick a cool Nerf gun on it.
Yeah, we're going to put a Nerf gun for the Zombie Tower Challenge. Challenge names are all kind of fun. All right, we can talk about the basic design, but first, Helena, do you want to say what you think you're going to do in terms of artwork?
Okay, so for this lunchbox spot, Bangers and Bash, we're going to have some vents here.
And that's to stop everything inside overheating.
Yes. And what I'm thinking, because it's called Bangers and Bash, I'm going to paint or put some stickers that have been designed on the computer on top of here, all around, or mostly around. And the little vents will act as grills for the bangers.
So what she means is you're going to have a grill with a bunch of sizzling sausages on it, with the vents being the grill bits, and we can probably get some LEDs behind it so we can make the sausages sizzle and change colours when things are, you know, just make it sizzle for fun. And then we're going to mount the Nerf gun on top of that, and I haven't quite figured out how we're going to blend it with the rest of it, but perhaps we can make it look like a hot dog.
Hot dog gun.
Hot dog gun. Shooting at Nerf darts. So, all right, the first part of the design, and this is actually Helena's idea, is we're going to reverse the lunchbox. So that's actually the bottom of the lunchbox. And instead of drilling holes in the bottom of the lunchbox, other than vent holes and potentially a camera hole, the bottom of the lunchbox is going to just mount on the top. The top of the lunchbox becomes the bottom of the robot, and the components are going to be putting on there with probably some 3D printed brackets to hold them. So maybe a few release screws under here to take off the electronics.
And the reason I chose it to be like this was because if it was inside here, my dad's hand, it's just too big.
And
it's just not big enough.
And that was a problem that I was having with this lunchbox robot. Now this lunchbox robot is tiny. It's exceptionally small. I've got a bigger lunchbox than this if we need it, but maybe we don't. But this one is tiny, and I must admit it's really fiddly. I mean, there were times when I had to go and get either tweezers or something else to get in there. And this, if you've read the articles, you'll know that this lunchbox is smaller than one I recommend, because I recommended a larger one in the articles. I just kind of made my bed and slept in it and went with, well, I'll stick with the one I've already got, but it is really small. So, yes, the article recommends a larger lunchbox. Use a larger lunchbox. Helena's idea of putting that on the bottom, fantastic.
Because then you can just go...
You get side access to components. I mean, and even then, when it's like that, I can actually get debugging, so I can actually go and plug things like, a keyboard or a screen in.
Yeah, because
I don't often do that because I do everything headlessly, but
it's better headless, and Bluetooth.
It's probably the wrong way around there. But so, all right. So what's the basic layout of this robot? So I'm going to have some motors that I'm going to mount outboard, because on this, again, we've got all this cramped space, and I put the motors inside. Now, putting the motors on the outside of this would give me a lot more space inside, make the robot a little bit wider.
And we're going to be using this on the bottom, so then there are only 2 motors, and underneath it will slide perfectly along.
Yep, on a ball caster we get very little friction. So the motors I'm going to use, I'm not going to use the big yellow motors. I went and shopped for some motors, and I'll show you what we've got first. These motors.
And I think these ones are the Lego motors, right?
Not quite. So these are from Pimoroni. They are micro metal gear motors, which I've already got one set before. Here we go. So these are geared, I believe, 50-1. It says on the packaging 50-1. It doesn't say anywhere else on the motor, I believe. And as Helena was about to get to,
these you can use some of these wheels. I think we might use these pairs.
So to do that, we need this other thing I got from Pimoroni, which is the Lego gear motor adapters.
Yep.
So we're going to use those, yeah.
So with those on, if we can pop those on later.
It gives us a choice. Oh, so the motor won't go directly in very well. It does need the adapter. But it gives us a choice of wheels. So
because these are Lego wheels, and we can, throughout the Piwars, we can adapt our wheels to fit the type of ground you're working on, or maybe we use these big fat things, and then we're on a smaller course, so we have to use these little ones.
We can figure that out. Now, it does mean we'd have to adapt code, because the other thing we're going to do with these motors is another Pimoroni part, is this. Actually, it's a Pololu part, but bought from Pimoroni too. So this is an optical encoder pair kit. Let me just zoom in. Right, so optical motor pair kit. So what this lets me do is I can solder one of these straight on the back of one of these motors, so it goes straight through there. The little windmill looking like bits are the actual encoder wheels, and then on these tiny boards are the optics to actually do the encoding, and so this would slot onto the back and be soldered on there, and then I'd solder something. Don't know if you can see the castellations, the little tiny strip there. So we'll get that on those, so each of these motors will have encoders.
One question.
Yep.
Can I do some of the soldering?
Yes, you can.
Yeah.
So in terms of sensors, and we'll come back to some of the drive bits later, in terms of sensors, this robot's going to have only a few sensors. So we're going to have a camera, main camera mounted on the front, which means there's going to have to be a hole there, but I might make it just a through hole here. So then the actual mounting is on the bottom bracket again. So this doesn't, I don't want this to really have too many wires, or if I can help it, any wires engaging with the bottom. There'll be a camera, there'll be encoders on the motors, and then there'll be an IMU. Now the IMU, there's a bit of a secret weapon going on there, so we're not going to give that away just yet. But the IMU at least might give us, if we can mount it in the right place, we might also be able to use the magnetometer and get some compass sensing from that. I mean, we've already got the dead reckoning with the wheels, and if you've learned robotics programming, you'll see that actually I can do quite a lot with dead reckoning from the wheels. Accounting for slippage, I mean, obviously, and rounding errors, it can still go out, but that'll work pretty well. Using the camera, you get a lot of situational, as in you can sense where you are in a maze, where you've got to turn, maybe. And I'm definitely going to shamelessly use some of the techniques that we were given in Piwars mini conference. The chap who made the rather amazing micro mouse used Bytes on Twitter. He gave a very good talk about how he's using the camera for his robot that basically has just got steppers and a camera. It has almost no other sensors, and it worked beautifully. It was the one that delivered the 20-second performances.
Was that the one that went all over the place?
And it was a little tiny mouse. It looked like a computer mouse. It was about this big.
Wow.
Yeah, I know. That's what everyone said.
That's
wow.
Just
and he just demolished the courses in no time.
Wow.
Yeah. But he gave a great talk on how he did it, and so I'm going to try and see if I can go with a minimal sensor approach. Because my previous robots, I went for everything but the minimal sensor, and basically I either ran out of time or ran out of space to make more sensors or ran out of ports to put them on. Because I'd have always more sensors, and actually maybe I could just do it with a camera and a couple of other bits.
I was thinking, so for the camera,
yeah,
maybe we could still drill the hole, so when it's off it will still look normal.
Yeah.
But you'd plug in the camera here. You could, over here, this is the front side I think.
Yeah.
You could drill a hole right over here, on here, with the drill. And mount the camera through here.
Yeah.
And then when you don't want it, you could just untie it and you could unplug it. So then you can have like a pocket-sized camera on your lunchbox, because this thing isn't big. It's not big.
It's the Raspberry Pi camera. So Raspberry Pi cameras plug in with these ribbon cables, so they're not particularly the kind of thing you want to plug and unplug often. And the camera itself is this tiny little board, just just in there. Can you see it?
Yeah, I can see it.
So it's a little bit more raw. Yeah, it's not like a consumer camera. It's just the camera module. It plugs in via CSI, which I think is the I don't know. It's a camera serial interface would be a guess, but I don't know the actual terminology. I've also bought from Pimoroni a couple of these brackets, which you can use to clip those motors on, and they hold them quite firmly. So I'm going to need to put maybe some CAD designs, just work out where I'm going to drill holes for this and for my board, so they don't interfere with each other. When I drill the holes for the motors, I'm going to make sure that when I figure out where they go on the bottom, that A, these stick out enough so that the wheels don't get stuck on the wings, and B, so I take account for the length of the adapter as well. I'm probably going to go with the idea, because they're Lego wheels, they're detachable, so we could take them off when we're going to open up and take the top off, so we could pop the wheels off and take the top off. If it's just Lego and clips, it's fine.
Yeah, because these, you just have to have an axle to go in through the middle.
So in terms of LEDs, I was thinking we could go with one of these LED shim, which is a whole bunch of fun. So we've got a whole bunch of RGB LEDs. I think there's 24 there, and that gives us as many colours as we want, and it fits rather nicely in this shell.
So 24 LEDs.
Yeah.
In that tiny, like, it's not even like an eighth of this board.
Yep.
It's tiny.
It's like a little bar strip. I've got some videos actually of me getting those LEDs doing something. Oh, there you go, you got it in focus. Yeah, I got videos of me getting this to do something and doing a kind of rainbow Larsen scanner, as in, rainbows going back and forth on it. And so on.
That would be awesome if it went with the rainbow colours.
Yes.
That would be actually quite amazing.
I have code ready that does that. I have code that does that. I don't know if it animates it, but there's code that does that in the book. You've seen the book? Learn Robotics Programming, Pact Publishing.
Read it. I didn't understand everything.
So, alright, the next thing to think about with this robot is a motor controller. When I was at Piwars, a mini conference, I saw Neil from RedRobotics, and I got one of these. This is the RedRobotics motor controller, and this is what I'm thinking about for this. Now, there's a couple of reasons this might and might not be suitable. First thing is, it might be overkill. For one of my robots that has every sensor in the kitchen sink. Sorry, Helena, do you want to...
And it's quite big for the little robot.
They're all going to be about the same size, I think.
I guess, but it's still quite big.
So, I'll just say what it's not going to be. The motor controller in this robot is not going to be an L298, right? That's totally right out. I did consider whether I could take one of these little tiny motor drivers, which drive from PWM, and that actually is almost functionally equivalent to the L298, just in a smaller, more power efficient and space efficient package. But I thought, well, let's try and actually go with what we've got on the Pi. If you go with a Pi hat, they're all going to be about this size, and this does a certain amount of power handling. It's got power switches, it's got a reset button, or a button that can reset or just give some data. It's got an LED that actually displays the last 3 digits of your IP address, so if you want to find out what your Pi is on the network, it does that for you. It's got what it calls, I think, the handy header here, and actually when you got one of these at Piwars Minecraft conference, there's a little OLED display that you can slot in. I've got one of those over there. So you can connect your 2 motors. You can have separate powers for normal motors, for servo motors, for the Pi. It's got a useful slot for the camera. All the best shims and hats have that now. It's got I2C breakout, 3.3 volt input and output, 5 volt output.
Rainbow sort of coloured
Headers. It's got analog inputs as well, so you can have analog sensors.
So actually, analog is like the time.
No, well, analog as in instead of being digital on and off, or I2C, which is some addressable thing, it means it can actually sense the level of a voltage or a resistor. And so sensors that only give back a level of voltage, it can work with those as well.
Interesting. So
this is a fabulously adaptable board, and actually my only real worry is I think it might be wasted in a robot that's got so few sensors, whereas one of the robots where I've stuffed as many sensors as I could, this will significantly reduce the amount of wiring I need. It will simplify. I mean, I guess the only thing it's perhaps missing is it hasn't got 5 volt inputs, so that's the only thing it's potentially missing. But if I was to take last year's Piwars robot, the big tank thing that never quite got named, but the 3D printed metal chassis tank, that one, this would actually be a fantastic way to upgrade that, because it would reduce the amount of wiring needed by quite a significant amount.
We don't want that, like, clumps of wiring all over the place in this one.
You mean like that?
Oh, jeez. Why? Why do you do that stuff? Why can't you just use Bluetooth?
Not Bluetooth inside the robot. All right, this is just for completeness, by the way. This is the little OLED shim that came for the RedBoard. So there were some other controllers in the running, which might also be handy.
Can I talk about it?
Yeah, you can.
So this is the Adafruit Crickit, the other way around, and for the Raspberry Pi, and it has pink bubble wrapping. Just saying, it's cool. I like it. Okay, should we unpack it?
Yeah. Get it open. That's it. Yeah, cool.
So a little label. That can take that. And here it is. So it's a controller.
You're struggling.
I can get it.
Do you want a knife for it?
No.
No.
I don't like knives. They can kill people. And it makes a lot of popping noises because it's bubble wrap to make sure that it doesn't like fall apart in the car or whatever van.
In transit. Okay, do you want to show them what we got then?
So we got some headers.
Mm-hmm.
That can fit into here. I think they.
So that looks like an extension header. My guess the extension header is there. A, so you can swap out the single header, or B, to avoid those pesky power over Ethernet headers on the Raspberry 3B+.
The servo here.
So you get a set of servo motors.
ID.
So Signal IO. So I think do those say 3 volt or 5 volts? So that's also for sensor input output.
They say 33 volts.
3.3 volts. That will be. So I don't know if it's just going straight to the Pi. I don't see much in terms of input filtering, so they might still be not 5 volt tolerant. Okay, cool.
Here we have like one of those tiny plugs.
Okay, that's a USB micro, so that's power.
And here we have another sort of
power
plug thing.
Yeah.
And we have a motor driver, I think that is.
Yeah, so you've got 2 motor outputs there.
Ground. You have ground there.
Yeah. Which,
ground.
What are those 4 or the 5 on the next one? Drive. Well, I don't know what that drives.
I think that's how it drives.
Well, no, that's not motors, so I don't know what that is. We'll have to go and look at the docs.
We have here the NeoPixel control.
So you know what NeoPixels are, Helena?
Yeah, they're like the strips, I think.
That's right, LED strips. Now, if we've got the light shim, we again that might be overkill, but that's cool.
It might be overkill. And
what are those 2 pins there? Is that another power input?
Speaker.
Oh, that's a speaker output. Okay.
Oh wow, we can make it speak like it. We can make it do sizzling noises whenever it moves.
Get your hot dogs.
Get your hot dogs. Hot dog
Ice
gun.
cream. Nice.
Hot dogs on ice cream.
It's also got capacitive touch, which I suppose you're not going to use on a robot. It would be more on a controller. So the thing is, both these controllers share one thing, which is they've really got everything but the kitchen sink on them. They're both incredibly adaptable and ready to use. They're both pretty epic controllers.
I think I like this one more because it has a speaker, and we can make it go sizzle, sizzle, sizzle.
Maybe. There is a reason I like this one more, which is this one tells you the IP, which means you can find the thing. Although I guess you could get it to speak the IP and you could get it to blink the IP. They are both epic boards.
I like this one more.
And it's possible that because they're so epic and because, you know, some of my other robots actually have many more sensors, that they get cannibalised off of this robot to go and swap for a PyCon Zero. Only because PyCon Zero, it's still quite a nice board, but it isn't quite as much kitchen sink as these. I mean, these are fantastic. Now, there is one thing I want to say about the Crickit. Right, so there's a couple of issues with this. So I've also got a lithium-ion battery, which will be a first for me because I've always either used the USB things or normal batteries. And I've got AA batteries. I've also got an Adafruit battery, it's a DF-Robot battery boost and charger module. So in theory, I can plug this in, 3.7 volts, right? So it's below the 5 volt. Stick it through this and get my 5 volts. And it should be able to handle a whole bunch of current. We'll have to find out how that works. This allows me to have a higher voltage level to drive motors from. And then we'll actually condition it for use with a Pi. And therefore it's separating power for the Pi and the motors and the servo motors. And one of my concerns is you get brownouts on the circuit where you get voltage levels drop because you're driving a lot of power to motors and high current devices.
What about the Crickit?
So the Crickit takes another slightly opinionated thing, which is that it doesn't mix voltages, so it's all 5 volts. Now, if I've understood it correctly, I think that means it doesn't actually separate motor power and Pi power. This should provide enough current if this can provide enough current, as in it's not just down to the battery, it's down to this voltage level converter and how much current it will deal with in amps. If it will happily supply the motors and the Pi, we shouldn't have an issue, but if it starts to droop, we will have problems.
I also like it because I had pink bubble wrapping.
Nice. So that's one potential concern is with this, we may end up with brownouts. With the other one, we're clear not to, but it says 7 volts upwards, which actually means we might need 2 of those batteries to get you 7 volts. Gives you also twice as much power, or get a bigger 7 volt set. You know, we can get a blocky one perhaps. We'll have to figure out compatibility. This charge and boost shim isn't really compatible with the RedBoard either. So if you're using the RedBoard, you'd have to charge these separately. Lithium ions, possibly even lipos. Also means we need to buy the fireproof bag. Fireproof bag to charge them in.
Because otherwise they might turn into fires.
Well, yes, exactly. Okay.
And we're thinking of the wheels being like these, right, Dad?
Yeah, big round wheels.
But I was actually thinking we'd take all of these. So these ones...
I'll take a bunch of wheels.
These ones are quite good, actually, for the rough mats, rough places.
They are, that's true.
And they're quite small, so it won't go up too much.
We do have one thing about when you change the wheels, you have to tell the robot which wheels it's got, because if we're using encoding to help us turn corners, and we're trying to do dead reckoning, then the size of the wheels actually matters, because it needs to know how far it's going to move for each turn of the wheels, which is going to be different. If you've got wider wheels, it's obviously gone further.
So these ones, I feel, are the best for like the compact, so the packed places. So I think they'll go on like here.
So I guess when we had was it the Canyons of Mars? I can't remember the last year's event. There was a very, very rough terrain event, and those wheels would be great on it.
Yeah, we had these.
No, we didn't have those. We had tank tracks.
Oh, we had tank tracks.
We had tank tracks, but the tank tracks were metal, and they actually got wedged in the I think the plaster molded stuff, and they also slipped on the ramps. So we'll have to try this on ramps and see if it's got enough power to handle quite steep ramps.
I can make a ramp with some stuff.
Oh yeah, we can make ramps.
With Lego.
We got a whole bunch of building, soldering, drilling. I actually have this lunchbox in CAD, at least the top side, not the bottom side, but I know what I've got to fit to in terms of size and
sticker sizing
footprint. And for your stickers, yes, we can put the stickers at the right size.
We'll have to get some of those gigantic stickers.
I might see if I can get a sticker print service when you know what you want. We can get someone. We haven't got facilities in our lab to print stickers, but if we want nice gloss or matte finish, you're in the art department.
Gloss, I guess.
Gloss. So we can get nice gloss stickers, and we can probably get them so they've been what's the word? Kind of die cut as well for us, so that we can just take them off and stick them on, and we might get a few done just in case we mess up applying the first one. So applying decal.
I always mess up. It's pretty much my thing.
Stickers, right? They always go on wonky. How many Lego models have you seen with wonky wonky stickers, right?
Lots.
Yeah.
I stuck on the sticker and I was trying to get it on perfectly and it went on like that.
Cool. So, we're going to try and figure out what motor controller. I guess it sounds like we're in slight indecision about which motor controller we're going to go with.
This one.
She likes that one. That one works with my power supply.
And it has a speaker.
I'm just worried about brownout. And then that leaves this one for the RedBoard for another more complicated project.
I'm just going to check out the RedBoard while you talk.
And check it out under the camera. Ask me questions if you like.
Does this have a speaker? Nothing.
Not directly, no.
A NeoPixel?
Yes, there. That is a NeoPixel.
Nice.
A single NeoPixel, but...
Adafruit Flora, I think, has 2 or 3.
Adafruit Crickit. Oh, Flora. Oh, you're talking about Flora. The Crickit has a direct output. Now, that's the other thing. So bear in mind that if we're talking about NeoPixels, this gives me 24 LEDs. Yeah? Right? And it feels kind of like then we've wasted the direct output of this, but that doesn't matter too much. This has got the one, so yeah, we're going to be using probably this because it's just I really like this board anyway, the LED shim.
Yeah,
or
it looks good.
We can keep that. So I've got reels of the NeoPixels, and I've got reels of the dot star compatible type things. As in, I've got different reels of different LED strips. So we could use this, or we could use the thing here and just use the cheaper LED strips. Yeah.
Maybe.
So we've got plenty of options.
I think this one, the LED shim, because we can't have too much weight on our robot.
But what we could do, the one reason we might use the strips is we'll be able to get the strips closer to your artwork, because this one is fixed in, it only fits right on the pie, so you can't move it around.
Nice.
So it might be that's why we get strips. So we've got a whole bunch of design decisions, but we know roughly what we're going to start with. There's going to be a day today of doing more CAD drawings, working out where holes are going to go, because the holes for where the pie is going to be, pretty much a fixed done deal.
I think the vents should be really evenly spaced on here.
Yeah.
And so then you can do the design. So I'm also going to be doing some designs. He's going to be doing some designs. Mine are going to be kind of robot-y designs, even though they're just designs for the outside.
Artwork. You're going to do artwork. I'm going to do the
stuff.
Fiddly bits.
Stuff.
Yeah. Cool. Okay. So when we've done a bit more and got a bit more progress, we'll show you. There's been some other stuff, rumblings in the background, where I've also been simulating some of the courses this year. I must admit, I am particularly fearing what was it now? The Eco Disaster event, which is where you've got barrels and you've got to push barrels into specific locations. Now, if that's done autonomously, that means your robot's got to figure out where the locations are, what colour barrel it is, and probably try to not push over other barrels on the way. So you've got some pathfinding stuff. So that's why I've simulated it.
Will be hard.
Yeah, that in terms of a code challenge, that's like, okay, that's up another level. That'd be very cool.
That's putting up the heat of the grill.
Oh yeah. Oh, right. On that bombshell, I guess it might be time to wrap this up. I hope you've enjoyed this, and if you're looking to build your own first robot, Piwars is a great community to be around for building robots. Even if you're a beginner, they've got stuff for beginners, or just to show up and see what people are doing. There's nearly always a robotics market there with like different robot bits, effectively, and Raspberry Pi fun stuff. And you could also buy my book, which gives you, from beginner, step-by-step instructions on designing, planning a robot, figuring out what the trade-offs are, writing the code, actually doing the assembly and build, troubleshooting, dealing with some of the issues. Takes you all the way to some cool behaviours that actually use the camera. So, like I was talking about earlier, using a camera for a sensor, perhaps using a camera to detect a coloured object and move towards it. That's covered in the book. Right, Helena, can you take us out?
Go make stuff and be awesome. Bye.
Bye.